talk a little bit about what's happened with Panfrost in the last year. So first of all, Boris is the one who started PanVK and has been a long time Panfrost contributor. I'm a bit newer to the Panfrost team, but I've been around Mali GPUs for a very long time. And we have also a big team at Collabora, so what we're presenting is the work of many people. I'm not going to list the people. You can see the names up on the slides here. Some people are here and some are not. But yeah, there's also some more people we will thank later on that's helped out. So first thing is the overview of what we're going to talk about. We're going to talk a little bit about the Mali V10 GPUs, which is what most of our work this year has been about. We're going to go through the progress since last year, and then Boris is going to talk about PanVK and kind of how we brought that project back to life. So, Mali V10 GPUs are what's sometimes called second generation Valhalla. ARM calls it a little bit differently sometimes. It is the GPUs which has the CSF command stream front end, which Boris presented about Panther and talked a little bit about the hardware at XDC last year. Models in that family includes the G310, 510, 610, and 710. We're only supporting 310 and 610 at the moment, I think, but they're pretty much the same. It's just wiring up. I think that's missing. They were unsupported upstream until earlier this year. We're going to focus a bit on the RK3588 simply because that's a popular SoC available in many devices using the G610. You can see there's a list of devices, but even more so we are focusing on even a bit more on the ROC 5B. So Collabora has a team that's working on enablement for the RK3588. They're doing some great work. We have images ready that you can just download and run on these boards. They are, as I said, focusing on the ROC 5B, but they are known to work on some other boards as well. Those images. So there's a download link here for people who wants to try it out. So since last year on the kernel and firmware side, we've gotten the firmware upstream, and that's shipping in several distros already. The Panther module landed upstream in kernel 6.10, and we have 12 contributors to the kernel module already, and that's expected to go up also. There's a bunch of new features. Most of these that I'm listing here are currently cooking and haven't landed yet. I think some of them landed very recently, but as for the Gallium driver, we've landed V10 support upstream since 24.1. It's conformant to OpenGLES 3.1 since June, thanks to Erik, who's sitting here. We've added a lot of new features, not quite as impressive as the NVK list, but we're happy with this result. And a ton of bug fixes and other things as well. PanVK, we've added V10 support there. V9 is still a big hole in the driver. We will look at that later, but right now it's not been our focus. It's still, unfortunately, an experimental Vulkan driver with only 1.0 support. We're working on it. It's getting better. We have a little demo if people are interested. So, I guess we can just show that. So this is VK Quake 3 running on PanVK, on PanVK on the Rock 5B. So yeah, as you can see, it's Vulkan and yeah, Mali G610 here. All right, so now I'm going to hand over to Boris.
Hello. So for those who don't know me, I've been Alisa's Padawan for a while, and nowadays I'm mostly trying to fix the mistakes I made back then. So that's a bit of what I'm going to talk about here. So yeah, PanVK, it's been a long way until we got that running on the newer ARM GPUs. A bit of history about PanVK. It basically started as me trying to understand what Vulkan was and how it worked. And instead of writing a Vulkan application, I decided to actually write a driver for it. So yeah, it was mostly a toy back then. I wanted to get simple workloads running, basically just VK Cube, and yeah, after that it went almost dead, which was a pain for basically everyone, not just myself. So it was a pain for all the users that were waiting for PanVK to become usable, other than just running VK it was a pain for Alisa, who had to maintain the generic stuff that PanVK was using, and Gallium was using too, the Gallium driver. And it was also a pain for the contributors that were occasionally wanting to use PanVK because it was regressing all the time. So yeah, when we actually looked at supporting newer GPUs, there was a question that raised pretty quickly. It was whether we wanted to keep the existing driver, or instead of that, just consider it dead and start from scratch. So why did we actually decide to invest more in the Vulkan driver? It's mostly because the newer gens of Mali GPUs, they were basically designed to support Vulkan. I mean, if you look at how they deal with descriptors, it's basically the model that they have in Vulkan. If you look at how you configure the graphics pipeline, you can tweak every little bit, and you don't have to re-emit good chunks of descriptors. You can just tweak the bits that you need to update. That's a big improvement compared to older GPUs. If you look at other complex features like secondary command buffers, there was nothing like that in older GPUs. The new ones, they actually support it natively. And I could probably have another dozen items in the list. It's crazy how V10 is actually meant to be Vulkan ready. The other thing was a growing demand in the open source ecosystem to have a Vulkan driver, an open source Vulkan driver for Mali GPUs. So that wasn't the case until recently. I mean, it was mostly Google wanting to have a Vulkan driver, but the rest of the world, they were pretty happy with GL stuff. It's now changing a bit, and we have more people wanting to have a competent Vulkan driver for Mali GPUs. And the last thing that actually made that possible is also the fact that ARM is actually now providing us more support than they used to provide us. And that means both help when we are struggling with stuff, or even contributing stuff of their own on both the kernel driver and the user mod drivers. So yeah, when we decided to support V10, we basically had a tough choice to make, which was, should we keep going with the existing driver and try to fix it iteratively, or should we just rip it out and start from scratch? And I mean, there are pros and cons for each of those options. If you start from scratch, then you basically can do it right from the beginning, and you don't have to suffer with all the bad decisions that were made back then, which means you get to the point of having a functional Vulkan driver faster than we would if you try to fix the existing one. You also get the best of the new functionality that a lot of people worked in the Mesa community to ease the development of Vulkan drivers, and you also don't inherit all the bugs of the old driver. Of course, you introduce your own bugs, so you get there anyway. On the other hand, if you fix the old driver, then you don't have to type the whole boilerplate that you have to type with Vulkan driver, which maybe saves you a week, maybe less if you're a fast typer. On the other hand, if you intend to support older gens, which, as I said, are not as Vulkan friendly as the newer ones are, you probably want to take into account those things. And the old driver was basically designed to work with older gens. So if you start from the old driver, it forces you to take those things into account rather than just discarding it and yeah, going for the new fancy stuff instead. And also, you can improve things progressively and see if they regress, because you knew that you had something kind of working before, and you can make sure that it works at least as well as it was before changing stuff. So yeah, we actually, I told you that I made a lot of bad decisions, and I tend to repeat that over and over again. So instead of starting from scratch, which seemed the obvious option, we decided to go for fixing the existing driver. And yeah, the goal was initially to actually progressively transition to all the new fancy stuff that we have in Mesa right now in the libvulkan runtime. That is using VK meta for a lot of stuff, which greatly helps when you have different gens to support, and each of them is slightly different, which makes the code slightly annoying to maintain with VK meta. Most of these this specialization is actually hidden, and it's easier to maintain. There are also a bunch of other stuff that VK meta that the Vulkan runtime does for you. A lot of the entry points that you previously had to code yourself, they are completely handled by the runtime now, and most of the time you just have to implement one of two features, and the rest of the features they get implemented for free. So that's a huge change too. And yeah, we did that progressively, mostly Mary working on that. So kudos to her for getting there and making the old driver pleasant to work with. So that was Vulkan on Bifrost, getting up to speed and pretty much comparable to the other existing drivers, Vulkan drivers. V10 support, it started a bit before we started cleaning up the existing driver, simply because we were able to start working on that before we decided to reuse the old driver. So what we did initially is fork the existing driver and then try to play with that and then patch it to support the new hardware. The big issue was that we depended on having a working kernel driver for that, and it only landed earlier this year. So basically, people were blocked waiting for that for a while. And when we got to having a working Vulkan driver for V10, most of the cleanup that were needed to resurrect the old driver were already merged. So instead of keeping out of tree work, we decided to just try to reintegrate all the changes we've done out of tree into Mesa main. And surprisingly, it went pretty well. I honestly thought it would be way more painful than that. So yeah, in the end, it wasn't such a bad decision, and we managed to get some V10 work, some Vulkan workload working on V10 pretty quickly. So that's what we did for the past 6 months, I would say. The plan for the future is twofold. First, trying to support more feature and achieve. So the first goal would be achieving 1.0 conformance. And then, of course, 1.1 and 1.3. I'm not too worried about 1.1 and 1.3, simply because we are basing most of the driver on the Vulkan runtime, which automates a lot for us. And then Face and a lot of other people, they design the thing so it would be easier for all the drivers to support the new fancy features. So I'm not entirely sure, but I think it's achievable and in reasonable time. And the fact that Alisa managed to do that with Unicrisp is a good sign that the Vulkan runtime is helping a lot there. So yeah, that's the plan. And the other thing is trying to see where we stand in terms of performances compared to the closed source driver. So right now we basically have no idea about how well the driver performs, simply because we didn't spend time on it at all. So next year we'll probably be spending some time on that and see where we stand and try to improve that. And of course, adding support for some optional features. But again, not too worried about that because, yeah, libvulkan automates a lot of that.
Yeah, so yeah, it's been a fruitful year for Panfrost. We merged the Panther changes. We merged V10 and Mesa. We got 3.1 conformant, and yeah, lots of improvements also on Bifrost. Again, thanks to Mary. V10 merged in PanVK, and all of this is available right now in Debian SID. So everything is upstream and ready to use. So yeah, the future is bright and nice, and everything is looking fine. We have some more longer term ideas. One is to rewrite Panther in Rust. Might sound a bit crazy because we just merged it, but there's some good reasons security-wise that customers often want this. Yeah, we want to reach 1.3 at some point, which Boris mentioned. We want to look into V9 support in PanVK. Maybe OpenGLES 3.2 at some point. And yeah, feature parity with the DDK where it makes sense. So yeah, there's a lot of people who's helped out with this. We mentioned the Panfrost team before. Faith and Daniel Stone has given us a lot of support in addition. Also, other major Panfrost contributors like Elisa, Italo Nicola, and Antonino. ARM has been super valuable in all of this. They have, a team that's now contributing upstream, which we think is fantastic. We're seeing, merge requests coming both for the kernel, which has been going for a while, but also for Mesa. which we're super happy to see. Yeah, and yeah, so they have a reasonable sized team there as well. So that's pretty much it. Thank you. We're hiring as usual. And yeah, any questions?
If nobody else has something to say, I'd like to say thank you for mentioning security. And thanks for providing an alternative to the blob driver.
So you mentioned you had your demo of the Quake Vulkan, which was great. So I assume next XDC you'll be demoing Quake 2 RTX.
Never say never. To give that a bit more of a proper answer, the currently available SoCs with Mali does not have hardware ray tracing supported. We are not going to emulate that in software for sure, but there are hardware on the way with this. It depends on when we get our hands on it and if it makes sense budget-wise and things like that. I mean, it's a big feature and it's not typically very much used by our customers. But we'll see.